Good morning, how are you all? We're going to do the counting principle today. I am going to tie this into our probability unit. This video is after the 3 tree diagram videos that I made and any other tree diagram videos that you watched. Okay, remember this is a shortcut to the tree diagram method. So if you read number 1, I went to Baskin Robbins. I could have a waffle cone, a sugar cone, or a cup. There are 32 flavors. I could have rainbow sprinkles, chocolate sprinkles, or fudge topping. How many combinations of ice cream can I make? So I just want to be clear in saying that if you go to Baskin Robbins, after you pick a waffle, sugar cone, or a cup, I know that you could have as many flavors as you want shoved in there. You could have all the sprinkles you want with the fudge topping. As long as you're going to pay the money, they'll put on whatever you want. For simplicity, I'm going to tell you that after you pick the cone or the cup, you can have one flavor and then either the sprinkles or the fudge topping, just to make it easy. Imagine I asked you to make a tree diagram with this. You would start out with a waffle cone, a sugar cone, or a cup, and then off of each one, you'd have to write 32 trees off of that for each flavor. Off of the sugar cone, 32, off of the cup, 32, and then off of each 32 flavor, you'd have to do rainbow sprinkles, chocolate sprinkles, or fudge topping. I would never make you do that. That's not testing if you know something, that's just making you waste paper. So we're going to use the shortcut way here. You have 3 choices. So choice 1 is if you want the cone or the cup. There were two cones, 1 cup. You have 32 flavors of the ice cream and the 3 toppings, right? Choice 1, choice 2, choice 3, and you multiply them together. You're going to be using a calculator. I'm going to be using a calculator, but when I say I want to see your work, this is the work I want to see. So we're going to do a couple of problems that deal with the counting principle. Okay, second one. Ever been to the Cheesecake Factory? Is it even open? I don't even know. I go to the Cheesecake Factory. There are 5 choices of appetizers, 11 choices of entrees, 6 choices for dessert. How many different combinations of meals can you have? So again, I'll tell you, if you have enough money, you can order whatever you want. Sometimes people just order a bunch of appetizers for dinner and share. But for this problem, I'm telling you, you have to pick one of each. Again, imagine I asked you to make that tree diagram. You'd start off with your 5 appetizers. Off of each appetizer, you'd make 11 trees off each appetizer. Then off each entree, you'd make 6 trees from there. It would get to be way too big to fit on paper. So we're going to do choice 1, choice 2, choice 3, right? Choice 1 is an app. Choice 2 is an entree, that's like your main course, and choice 3 is that dessert. So for choice 1, you have 5 choices for an app, 11 choices for an entree, 6 choices for a dessert. Use my calculator to multiply them together, and you get 330 combinations. Okay, now I could turn this into probability. Let's say I told you what the 5 apps were. I told you what the 11 entrees were. I told you what the 6 desserts were. And then I turned it around to say, what is the probability Mrs. Conlon would pick mozzarella sticks for an appetizer, chicken for an entree, and ice cream for a dessert? You would say 1 out of 330. So this is going to kind of lead into more probability. Okay. Danielle is a combination lock on a suitcase, carrying top secret world domination plans. If he can choose any digit 0 through 9 for each of the 7 digits in the combination, how many possible combinations are there? Okay, so let's be clear, 0 through 9 digits is really 10 digits because 0 counts as a digit. So here's my combination lock, right? Choice 1, 2, 3, 4, 5, 6, 7. Daniel's going to choose the numbers that go in there. For choice 1, he can choose 10 different digits to go in choice 1. He's not choosing the number 10. You can't put the number 10 in the first slot. It's 2 digits. He can choose 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, 10 different digit choices to go in slot 1. So this represents slot number 1. He's going to choose a digit to go there in his combination lock. Okay, you can repeat digits. If I choose a 9 there, I could choose a 9 again. I could go 9999999 if I want to. I can repeat digits. So there are 10 digits that can go here and 10 digits that could go in each slot because you can repeat digits. If I multiply them all together on my calculator, I will get, I think I got this right, that there are 10 million different combinations that Daniel can choose to make his combination lock. Next, Annie is riding a bike very quickly to get to Daniel's suitcase. Mia is trying to stop Annie because she's on Daniel's side. Chloe has offered to paint Annie's bike. There are 13 colors of paint, 10 choices of trim. Mark says he could put on straight or curved handlebars. How many different selections are possible? Okay, you didn't need anything up to here, right? So this is me giving you a ton of information that's useless. You should be used to math teachers doing that. Okay, there's a lot of information in there you don't know. So this is where we have 3 different things to choose from. Choice 1, we are going to choose the paint. Choice 2, we are going to choose the trim. Choice 3, we are going to choose the handlebars. So for the paint, we have 13 choices of paint. We have 10 choices of trim. And then we have straight or curved. We have 2 choices. I showed you my work. Everything is labeled. Now I'm using a calculator to say that there are 260 combinations. Okay, so now we can also do this the boring way. I didn't even tell you what the events were. Okay, quite boring. I just said event 1, event A, there are 9 outcomes. Event B is 16 outcomes. I could have called it event 1, event 2. Either way, you're doing straight up multiplication. Now I showed you my work. I'm doing it on my calculator to get 144. Okay, that's how many outcomes there are, right? I could also do it with 3 outcomes. Boring, I didn't even tell you what they were. No fun word problem to work from. And I'd use my calculator and I'd get that answer. Notice I'm switching between a multiplication sign and a dot. I don't even know why I'm doing that. Okay, so now, this might be new for some of you, the word factorial. If you could see number 1, it's actually 6 factorial. That doesn't mean 6, right? Exclamation point. That means 6 factorial. If you look at your calculator, some calculators have a factorial button. You don't need it on your calculator. But if you have it, it might be a good shortcut. Here's what it means. You start at that number, you count down, and you multiply. Using my calculator. After you do enough probability, you'll probably find shortcuts and memorize that 6 factorial 720. They tend to use that one a lot. Okay, this is going to be, right, start here, count down, didn't need a calculator, start with that number, count down, use my calculator. This is another one, I don't even need my calculator. I've really memorized these 2 after all my years of doing factorial, and that one was just easy. Same thing with this one. Okay, so now we did the shortcut of counting principle, and we learned factorial, and all of this will help us with probability. So I will show you my activity for the afternoon. There we go. go. I'm going to be doing some planting this afternoon after school's over. And no doubt, my little girl Daisy will help me. Oh, there you are. And there is my little boy. There's my little boy. There's Lucas. And this is Mrs. Conlon signing off.